Hello everyone, I am Ramakrishna, working as Assistant Professor in the CSC department at VIGNAna JYOTHI Institute of Engineering and Technology. So today in this video, we are going to discuss about the UML diagrams. In the previous videos, we have discussed about the use case diagram, interaction diagrams and class diagram. After these diagrams, then we are going to discuss about next in this video state chart and activity diagrams. So a state chart diagram represents a behavior of a system by modeling the flow of control from one state to another. So it captures how an object changes its state over time in response to various events and defines how it reacts to those events. So we are going to capture the behavior of that entire application, that is from starting state to ending state. Whenever you are executing any functionality, so that function, how it works from the beginning to end, that we are going to capture. And likewise the entire module and entire submodules, the whole system, how it works from the beginning to ending. Suppose you take an example, when you enter into the ATM room, you start with inserting the card. Once you insert the card, what is the state? It is that card reader will read the debit card, and based on that signature and based on the connection given to the database, it will verify it is whether this is a valid card or not. So likewise, the step-by-step process, when it is validating the PIN number, when it is validating the debit card, when it is validating the account, and when it is validating the amount, and when it is debiting the amount, and all these things will be, you are showing it as a state. So the system, how it is moving from one state to another, that will be captured with the help of state chart diagram. So what it contains, what are the common properties? Just like the previous diagrams which we have discussed in the last videos, same way here also this particular state chart diagram has a name and graphical elements. Also, these particular state chart diagram focuses on the states and transitions, that is from objects over their lifetime. So when it will start reacting, when it will perform the operation, when it will end the operation, all these things will check clearly under this particular state chart diagram. So a typical state chart diagram includes simple states, substates and history state is there. So also we are going to discuss about the transitions. Transition means the arrow between these two states indicating the transition, that is showing the movement from one state to another. So also in this it is going to include events. Events will trigger the transition. So whenever you want to move from one state to another state, it has to satisfy any condition, or without satisfying condition also it will move from one state to another state. And the actions, so it will be taken during transition. So it is when it is moving from the one state to another state, what action it is performing, that will be shown with the help of actions. So if you see this right side, so here this is the start symbol, so to start the operation, and this is the end symbol to stop the operation, and this is the way you are showing. So this we have discussed in the previous videos. This is about the behavioral element. So we have things, 4 types of things that we have discussed in the previous videos: structural things, behavioral things, group things and annotational things. And so this particular state machine will comes under behavioral thing. So initially it will be in idle state, then here it is event trigger. That is, so whenever it is moving from one state to another, so initially it is in a noise state, then it is going to searching state. Then here if you see this, without any trigger, it is just moving from one place to another place, that is from searching to engaging. If you see this here, it has to satisfy one condition, that is called guard condition, that we are doing is threat, that we are checking here. Also it is performing the action. So add target. So by satisfying the parameters, so it will perform this action. This is called event trigger with parameters. So whenever you want to move from idle state to tracking state, so it has to satisfy the condition. Also it will use the parameters to perform this particular method. So likewise, we also have a self transition. Like it just want to check something. It is just like for database, whenever you are adding something or whenever it is updating something, it will just refresh the things that you will do with the help of self transition. So there are two types of transitions. One is from one state to another state. Another one is self transition. That is, it is going to the same state. So for that, we are providing the condition. After 2 seconds, this will become a live, so that it is doing with the help of a signal, send signal or time event with the help of this. So time event is showing that clearly after how many seconds it will be active, or how much time it has to be in an idle state. All these things will mention clearly. So here a state is a condition. So during an object's life cycle, so the state you are representing is like a rounded rectangle, and initial state, this is the starting point. So whatever the black circle is there, this is the starting point, and final state, it is black circle followed by hollow circle, again filled black circle within a hollow circle, that is the final state. And coming to the components, you have a name for each one: idle, searching, engaging, tracking, engaging, like that. And you have some entry and exit conditions. So here it sometimes we have a condition like this: noise or threat or something like that. Sometimes we don't have any condition. So without any condition also, it will move from one state to another state. And while exiting from that state, it has to satisfy some conditions. While entering into that also, it has to satisfy some condition. It is completely based on the requirement. And we also have our internal transitions. That is, whenever it is moving from one state to another state, that is called it as a transition. So these lines, so these are transitions. And we also have sometimes substates. State within a state, if you have another state, that is substate you are representing. So if you want to specify it clearly, that is called nested state within a composite state. So, and we also have a deferred events. So here in this, some events postponed for handling the another states. Like it will engage something and then it will stop for a while, and then again after some time, then again it will continue wherever it has stopped. So likewise it is performing. So for that we are providing the deferred events. So see this here, this is call it as a composite state. So within a state we have a substate. So that this is the way you are representing. And we also have a sequential substate here. That means step by step, like validating, selecting, processing, printing. In this way you are executing in an order. So that is called it as a sequential substate. So within a state, again we'll use the start symbol. So there it will perform the all substate transitions. So, and also sometimes we'll apply some parameters, conditions for this also. So here if you see this, while entry it has to perform read card, while exiting it has to perform eject card. So in this way you are doing under state, within a state. And here, so this will be done. So from idle state to active state by whenever you insert the card. So here it is what is happening. It is just transitioning to composite state. This is called it as the composite state. That means, so a state consists of substates. So likewise it is performing. So whenever the operation of this is over, like after printing stage, then it will go back to idle stage. So here sometimes whenever it is required, it will perform the maintenance stage here. So likewise this is performing. So this is called maintaining the substates under the state. So also within a composite state, again you are performing all these substates in a sequential fashion. And here this particular operation, while performing this here, so it is for every step it is doing clearly with a guard condition. So do you want to continue or you don't want to continue, all that based on that only it will perform the transition from one state to another state. And here it is when it is performing here. So this should be done in a sequential fashion. One is validating, then selecting, then processing, then printing. After completion of this only, it will move back to the idle state. In this way, it will perform this. So during this operation, so here it will be in an active state, and again once it is come out from this area, then it will be again under idle state. So this is another type category, concurrent substates. Under the composite state, again what we are doing is you are running parallelly two states. One is the testing, second one is commanding. So both will start at the same time here, and both will stop the operations here only. And here without condition it is going to the next state. Here it is when you press the key, then it will perform this command, and again it will continue back to waiting operation. So these two testing and commanding operations are called concurrent substates. So this will be done based on the conditions like continue, not continue, likewise. So here this will be done under substate, under composite state. This will be executed. And just now we have discussed, along with the composite state, composite substate, along with the sequential substate and concurrent substate, we also have another category is a history state. So what it is doing is simply it is remembering that. So what exactly you performed, what is the navigation you have done from this first step to next step, all those will be here. It will remember, it will back up, and this will be represented as H. This is called it as shallow history state. So within the state, again it is performing the collecting, copying, cleaning up, and it will perform, it will just remember the previous history, and based on that it will continue executing all those while backing up this content. So here if you see this state chart diagrams here, these are the elements comes under this. So particularly entry action, whenever it is entering into that state, it has to satisfy that some condition. So like this one, so whenever it is doing entry action, so it will set the mode on track, and whenever it is exiting, set the mode off track, and whenever it is moving from one state to another state, internal transition, then it will execute this particular tracker.acquire, and while performing any state, it will just follow the target where it has to reach. So that will do this activity, ongoing action performed while in the state. And deferred events are like sometimes self-test, sometimes just event will be postponed for a later state. So these are the 5 elements will occur under the each state. And coming to the transition, both are important, state and transition, because transition will connect these states. So while performing this transition, just like the state, here also we have 5 elements. So that is source state, event trigger, guard condition, action, and target state. These are the elements we have like state. So here this will be performed in this way. So with the guard condition, just now we have discussed, and it is running the time event, or it is running the send signal, so or it is running the action. What will be the starting state, that is first state, and what will be the last state, target state, all those will be executed here. Source state, destination state, like this. So it will start initially from idle, and if required it will perform this self transition. That will be done after 2 seconds, every 2 seconds, and it will be active. Then it will go to the next state searching, or it will go to tracking state. And whenever it is going to the tracking state, it has to satisfy the condition that is called guard condition. Also it is taking the parameters, that is called event trigger with parameters. So based on that, this will be executed, and when it becomes true, the guard condition, then only it will enter into the tracking state. If not, it will go back to idle state only. And after discussing every diagram, so we are discussing about the common modeling techniques. So we have common uses are to model the lifetime of an object, and to model the reactive, that is event driven objects are there for state chart diagrams. So when you model the lifetime of an object, so first set the context for the state machine, whether it is a class, or whether it is a use case, or the system, or whole. So how you are capturing the behavior? Is it individual class, or it is a subsystem, or it is a whole system, or it is a use case? That you are going to check first. Then you start establishing the initial and final states for the object. What is the initial state and what is the final state? Then consider the events, time events, different send signals, all those different types of events we are going to check. Based on that, that object will respond. And starting from the initial state to the final state, so it will check layout the top level states the object may be in, because just now we have discussed there are substates. So composite substates are there, sequential substates are there, concurrent substates are there. So based on the situation, you identify all those. Wherever it is necessary, you apply all those based on the requirements. Also you apply entry and exit actions, and you apply guard condition and with parameters and all those signals whatever required. So you identify and you then apply, and if required you also add a shallow history state to remember something when it is moving from the one state to the another state. And while leaving it from the substate, then you have to check clearly after satisfying the condition only it will go back to the previous state. So all these things will be done under this modeling the lifetime of an object. And coming to the modeling the reactive objects, here sometimes whenever it meets the condition, it has to perform some action, it has to react something for that action. So choose the context for the state machine again and decide on the stable states of the object. Start with the high level states of the object and only then consider its possible substates. Then decide on the meaningful partial ordering of stable states over the lifetime of object. So there are so many types of states we are using, whichever is the suitable for this particular operation. So choose that one and apply and attach the actions to these transitions and or these states. So consider ways to simplify your machine by using substates, branch, forks, joins and history states. So wherever condition is required, that is called branch. Wherever division is required, that is you are doing with the help of fork. Wherever there is a joining is required, again you are doing with the joining. Wherever you want to remember something, then you are doing with the history state. Wherever there is a separation required to perform concurrently or to perform in a sequential fashion, then we are using substates. So likewise you check clearly the source state, target state, entry action, exit action, everything wherever it is needed. So you apply all those based on the condition. So this is the way you are representing. See this, we have some self transitions, we have direct transitions, and we have some conditions here, and we need to satisfy all this. Based on that only it will be going to the next level. So this is the way it is reacting from waiting state to getting token to getting body, and getting body to again waiting state. So it is completely based on the condition. When it is true, it will perform. When it is false, it will simply idle, it will become an idle state. Then next, after state chart diagram, we are going to discuss one more important diagram, is activity diagram. So here activity diagram is just like a sequence diagram, but in the sequence diagram there is no conditional flow. There you are showing only sequential flow without any condition, but generally in real time you should satisfy the condition. Only when it condition met, then only it will move to the next state, then only it will execute the next operation. So otherwise the protection security will not be provided properly. So every level it has to satisfy the condition. So that you are going to check clearly. Also you are going to check the each individual user involvement while performing the operation. Suppose you are taking the money from the ATM machine. So not only we are showing the user responses, user activity, also we are showing the bank side admin actions, also we are showing the third party actions, database actions, everything we are showing clearly with the help of swim lane diagram. So because of doing this, you will be knowing very clearly about what exactly is happening, not only in the front end, also in the back end. So what is meant by activity diagram? It looks like a flow chart that you have already done in C language, C++, C++, Java, while writing the code, that will be pictorially represented using flowchart. So this is like showing the how control flows from one activity to another, and it is showing how the actions or events processes over time. So for state chart diagram, you are concentrating on a whole system or subsystem or a particular class or a particular event. Likewise, here also in the activity diagram, you are particularly focusing on an operation, each and every operation, how it works and how it will perform, how it is satisfying the condition. If it is satisfying the condition, what is the next step? If not, what you have to do? So all these things clearly it is showing, that is useful for the modeling workflows in software or processes in real life. So here, what are the key features of this activity diagram? It is focuses on the flow within the system and not between the objects like interaction diagrams. So it is completely under the system how the flow is happening, that it is showing, and also it is represents the logic of business processes, workflow or use case behavior. So what it contains, just like the state chart diagram, here also activity diagrams contains activity or action states, transitions and objects are there. And this is the way you are representing. So state chart symbol again. So this is having the names, simple names are there. We have so simple action, expression, make payment, all these, and this will be represented as a rounded rectangle. So here this activity will be performed. So while performing this one, again it will be done with the help of transitions from one state to another state after performing this activity. So for that we are using transitions. So transitions we are representing like this arrows. So again here also, just like the state chart diagram, the initial state, that is the start state, you are representing like this filled circle, and stop state you are representing, that is end state, like this. So here, so again just like the same state chart diagram, here also the same story. The only thing is you are adding so conditional flow in this. Also it will be represented in a swim lane model. So this is the way you are adding the conditional flow with a rhombus symbol, and while executing this, while moving from one state to the another state, it has to met this condition. If not, it will go to stop operation or it will go to back. So if it is satisfying, then it is going to the next state. So likewise, in every level you are going to check the guard condition by using the branching. So you are going to check whether it is valid or invalid, whether it is true or false, or yes or no. Based on that condition, you will decide it whether it will go to back or simply will go to stop the operation. Then here, wherever it is required, suppose I want to perform few operations parallelly under the single operation like sub operations, then I will apply the fork concept. By using the fork, I will divide into, so this is the representation of fork, graphical representation. I will divide into two parts. So parallelly I will do this charting and play game. Later again with the help of join, again I will combine these and perform the operation. So this is the way you are doing with the help of fork node and joining a thick line. So you are using between these states. And this is the way of representing swim lanes. So here you are involving the customer point of view, sales point of view, warehouse point of view, all these. So how they are reacting for each and every operation. Always you are going to start here and you are going to perform the activity. After that you are applying the fork operation. One is going directly and second one is going to the sales block. There they will perform process order and that will be moved to warehouse block. There they will perform pull materials, ship order, and these two operations will be parallelly done. This will be merged with the help of join operation. And after joining this, again what you are doing is simply, again you are doing splitting with the help of fork operation, and this again it will be receive order will be done at the customer side, bill customer will be done at the sales side. Later these two will be joined, and finally you are paying the bill at customer side and you are closing the order at sales side, and this is the stop operation. So this is the way while performing any operation. So not only the user, also in the back end who are involving to complete this transaction, to complete this operation, we are showing all those persons' behavior, their activity, their representation, everything we are doing with the help of a swim lane concept. So this is the way you are representing. And after the after discussion of every diagram, then we'll discuss the common uses. Here in the activity diagram, this is comes under dynamic aspects of a system. So in the previous videos we have discussed all UML diagrams are divided into static and dynamic aspects of a system. So coming to the static part, we have discussed like class diagram and object diagram. So those two, and next whatever in the next video we'll discuss the component and deployment diagram. Those two also comes under structural diagrams. Coming to the behavioral diagrams, that is showing the dynamic aspect of a system, remaining 5 like use case, sequence, collaboration, state chart and activity, all these 5 are comes under behavioral diagrams category. So here this activity diagram showing the dynamic aspects of a system, it is we are using to model a workflow, that is from the beginning to end, how it is flowing from one state to another state, how it is performing with action, and how it is doing with condition, without condition. So all those things will be shown. Second one is to model an operation. So first one is modeling a workflow. In this way you are representing, so you are checking clearly what are the responsibilities of the each individual swim lane and how it reacts, and also we are adding some additional mechanism like we are showing clearly the status of that particular item, that is the object state you are adding, and also you are just giving the its condition, its status, like object is item is returned, item is available, all those clearly you are showing the status of that particular operation. So based on that, customer will get to know that clearly status of that particular item. So in this way we are going to check the preconditions, post conditions and guard conditions, transitions, and when it is moving from the one activity to another activity, whether it needs to satisfy any condition or it will directly go to the next state, and if there is any need, will divide into parts of, if later you will combine with the help of join. So all these things you are doing in this activity diagram under the modeling a workflow. And modeling an operation, a particular operation, how we will do, like we'll start the operation, then it has to satisfy the condition, if not it will go to stop the operation, otherwise it will go like this, again it will execute the remaining operations, and finally it will stop the operation. So while doing this, you need to check clearly all the parameters, attributes of the enclosing class and the neighboring class, whatever required to satisfy this. Also you need to check preconditions, post conditions clearly. Based on that only you should move to the next level. So in this way you are going to check each and every operation particularly. So then only the customer will understand very easily. Then not only the users, also the developers, testers, everybody will understand this design part. So that's all about the activity state chart diagram and activity diagram. So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.